right, we're back. I'm going to give you a little bit of an insight into what's going to be doing, and I'm going to post today, or tonight, I should say, solving systems of inequalities. Not that difficult. It's just taking systems of equations and graphing them like inequalities that we did before. There's some rules that you need to know. I'm going to put these up right now. I'm going to do numbers 1 and 2 for you. I'm going to do those for you on my whiteboards. Then I'm going to let you work on numbers 3 and 4 on your own. Number 3 and 4 are very, very, very similar to numbers 1 and 2. So it shouldn't be that big of a deal. As a matter of fact, I think the way that it's written is like the other test, where the first 2 and the second 2 are exactly the same type of problems. It's just that the teacher, we split them and we used the top half as one part of the quiz, the bottom half as the other. Whatever, doesn't matter. Systems of inequalities. Biggest thing that you need to remember, if it is a greater than or a less than sign, just the basic greater than or less than sign, it's going to be a dotted line. That you should know from graphing inequalities from before, the previous test on this chapter. The greater than or equal to, less than or equal to signs are a solid line. That's the solid line. It includes the points that are on the graph, and I'll explain it as I graph further. Now, the part down here that I sort of put my thumb through, look for where the shading of the two problems overlap. That's the answer. Now, what do I mean by that? This is what I mean. Let's look at the very first one, this sucker right here. Y is greater than 2/3 x minus 1. Y is greater than 2/3 x minus 1. Okay, let's graph that first one with green. -1 is the intercept, so boop, there's my first point, and my slope is 2/3. That means I go up to right 3, up to right 3, or down to back 3, down to back 3. So that's what my graph should look like. I could go further. I don't need to, okay? Now, here comes part of it and why it's nice. It's a less than sign, so it's a dotted line for my graph. Why that is? Because these points actually will not work for the problem. I can't take the ordered pair of 0, -1, put it into this problem, and it'd be a true statement, because if x is 0, that wipes out. -1 is not less than or greater than -1. They're the same. They're equal. Okay, so that's why it's a dotted line. We have to shade. Remember that? We have to shade the graph. How do I test the shading? I take the origin, 0, 0. I put 2/3 times 0 minus 1 and put the 0 over there. I substitute the 0 for the ordered pair of the origin, 0 in for the x, 0 for the y. They wipe out. I'm left with 0 is greater than -1. Is that a true statement? Yes, it is a true statement. So because it is a true statement, I have to shade my graph that contains the origin. The origin is right here. That means everything up here will be shaded green in this case. Now, this is where if you've got different colored markers, it's going to be beneficial for you, okay? It'll be beneficial to have different colored markers because it'll be nicer to show. Because we're looking, like I said before, for where the two graphs' shading areas overlap each other. Let's look at the next graph. Y is less than or equal to, so I know right now it's a solid line, less than or equal to 2x plus 3. So plus 3, 3 is my y-intercept, and 2x, 2 over 1, up 2, right 1, up 2, right 1, up 2, right 1, or down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1. I'm not looking like in systems of equations when I'm graphing them. I'm not looking for where they cross. I'm not looking for that. I'm looking for where the shaded areas overlap each other. I've got to test the origin, 0, 0, into this problem. 0 is less than or equal to 2 times 0 plus 3. Oopsie, 3. 0, because I changed the y for the origin into 0, is less than or equal to 2 times 0 wipes out plus 3. Is 0 less than or equal to 3? It is. That means everything that contains the origin on the blue line, everything that contains the origin, which is right here, has to be shaded. So it's over here. Now, You have to look at this problem and find the one area, the part of this graph. Let me get a different colored marker. The one area of this graph where they overlap each other. Now, if you've got the ability like I have, I can erase the parts of this that don't overlap. If you don't, then you've got to do something like this. Here's the overlap. This area here. Everything in here. That is the true answer, okay? Just the red area. All those points that are contained in that wedge could be taken and put into both of these equations or inequalities and make them a true statement, okay? That's what you're doing. You're just graphing two lines and shading, which is the goofy part with inequalities. That is the goofy part, I'll agree. Okay, let's do number 2. Okay, the second one, it's exactly the same. Okay, I'll make it a little bigger just because I'm a nice guy. Let's get it. Make it a little easier to read. Okay, here's number 2. Y is less than or equal to 3 over 2x minus 1. Okay, 3 over 2x minus 1. Y-intercept, -1. Slope is a positive 3 over 2. Up 3, right 2. Up 3, right 2. Up 3, right 2. Or down 3, back 2. Down 3, back 2. I don't need to go that far. It is a less than or equal to sign, so it will be a solid line. Now, I showed you before, I could take one of those points and put it in for that inequality, and it would make it a true statement. Now, this next one is tricky. Be very careful with this next one. The next one tells you all numbers less than 2. X is anything less than or equal to 2. Any number less than 2 on the x-axis. First off, since it's x equals, go to x on the number line. It is right here, 2 on x. And it tells you all the numbers on x that are less than 2. That means everything this way. So this is a vertical line at 2. And it's a solid line because it's less than or equal to. All right, oopsie, what did I forget to do on the first one? Silly children, I forgot to graph it. All right, so let's go back in time, pretend this blue line is not there. I'm going to take the origin. 0 is less than or equal to, this wipes out, -1, because 0, 0. I put the origin into this problem. 0 is less than or equal to -1. Is that a true statement? No, it's not a true statement. So you're not going to shade the side that has the origin. You're going to shade the opposite side. Okay, the opposite side of that equation. Okay? Oh, forgot to shade it. Now I'm a little out of order. If that messes you up, I'll do another one later. Maybe, maybe not. This one says all numbers less than or equal to 2 on the x-axis. So that's everything this way, shaded this way. Okay? We now have our two lines graphed, and we have them both shaded. We have to find out where these two lines overlap each other with their shading. This part right here. All this in here. All those points in that wedge that is shaded greenish are the points of which could be taken and put back into the equation for x and y. Any point in here could be taken and put back in. Let's take one of the easy ones. Let's take 1, 0. Write 1 up and down 0. 1 makes this 3 over 2 minus 1 would be just 1/2. Okay, I'm sorry, I'm talking down here and pointing up here. Put a 1 in for the x, okay, and a 0 here. Is 0 less than 1/2? Yeah, it is. That's true. Now I put a 1 here. Is 1 less than 2? Yes, it is. It works for both of these. It doesn't matter what y is in this one because y is anything. Any number that you put in there it could be y because it never will be bigger than 2 for an x value. Okay, is this making sense? If you don't understand one of these, just remember if it's x, it's a vertical. If it's y, it's a horizontal when it's just the variable like that. All right, good luck. I'll be coming out with another video probably a little later that tells you what tomorrow's test is going to entail. I can tell you right now, but I'm at 9:57. I'll make it fast and then I'll give you one later. It's going to give all of you a second chance with graphing and equations, a second chance with graphing and equations tests, okay? Second chance to pick up your grade from there, which all of you need. And then it's going to be a short test on systems of equations. Systems of equations with graphing, with substitution, with elimination, and then systems of inequalities, like one problem with inequalities. All right? So, this is what's going on tomorrow. Test of graphing and equations to give you a second chance of doing better on that, and then systems small test to give you a start there, which is actually the start of second semester in algebra. So that's what you're doing tomorrow. Makes sense? Second chance on graphs and equations, first chance on systems of equations and inequalities. Talk to you later.